Hi, I'm Christoph Ratgeber, working at ZAE Bayern, the Bavarian Center for Applied Energy Research. With this video, I'd like to present you our project High Performance Transport Materials for Thermally Sensitive Vaccines. This is a contribution of the Technology Collaboration Program on Energy Storage to the IEA initiative Today in the Lab, Tomorrow in Energy. I like to present our project following 4 questions. First, what is the aim of the project? Second, how would the project be explained to a high school student? Third, how does the project help to achieve climate and energy goals? And fourth, what government policies could advance this project? The project itself is a collaboration of the company Vacutech and ZAE Bayern. How would the project be explained to a high school student? Some COVID-19 vaccines need to be stored at -70 to -60 degrees C. Their worldwide distribution is a major transport challenge. Today, thermally well-insulated boxes with dry ice, which is carbon dioxide, for temperature stabilization are used to keep the vaccines cold. In our project, to replace dry ice, the transport containers will be equipped with phase change materials, PCM. PCM melt and solidify to release and store cold. PCM are reusable, and PCM are selected based on their melting temperature to suit the application conditions. What is the aim of the project? It is to develop cold storage materials, PCM, to transport COVID-19 vaccines and other pharmaceuticals in the temperature range -70 to -60 degrees C. In the project, as PCM, we are using aqueous salt solutions that release heat when they freeze and that take up heat again when they melt. This is shown at the bottom here for the transition from solid to liquid. The PCM technology is adaptable. The transport boxes and containers with PCM are already being used successfully for other temperature ranges. The objectives of the project are identifying and investigating potentially usable PCM on a laboratory-grade scale by performing calorimetric measurements, tests of nucleating agents to promote crystallization, and thermal cycling experiments to ensure long-term stability. On a larger scale, tests of the PCM and cold packs and trials of PCM production on pilot plant scale are performed at the company Vacutech. How does the project help to achieve climate and energy goals? First, unlike dry ice, PCM cold packs are reusable. Second, freezing PCM cold packs can be more energy efficient than producing dry ice when efficient cooling equipment is used. And third, due to the quantity limitations of using dry ice, which is a hazardous good, in enclosed transport spaces, the use of PCM allows larger quantities of pharmaceuticals to be transported at once. What government policies could advance this project? First of all, setting a higher CO2 price could improve the economics of cold packs. Second, establishing ambitious targets for the reusability of cooling solutions to boost the replacement of dry ice by PCM. And third, increasing global vaccine distribution could also promote the use of reusable PCM boxes. With this, I'd like to thank you for watching this video. Please feel free to contact me if you are interested in the project. I also like to say a special thank to the German Federal Ministry of Economic Affairs and Energy for funding this project and to the IEA for the opportunity to present our project in this context.